afternoon of May 15, 1954, Mrs. William E. Boeing, wife of the founder of the Boeing Airplane Company, christened a new airplane. Then, America's first jet transport, the Boeing 707, was towed into the sunshine. The new airplane, a prototype jet transport, has been built and wholly financed by Boeing for use as a demonstrator to show the airlines what such an airplane can do on commercial air routes. The primary design objectives of simplicity and reliability have been strictly maintained. It is a brand new airplane, but it bears a definite relationship to Boeing's preceding jet airplanes, the B-52 and B-47 bombers, having similar swept wings and pod-mounted engines. Compared with the Boeing Stratocruiser, the new airplane is somewhat longer, but of a lesser wingspan, making it readily adaptable to present field space and hangar facilities. The forward cargo door opens on the 90-foot-long cabin. In this prototype airplane, the cabin is unfurnished, except at the forward end, where flight test instrumentation is installed. Forward of the instrumentation area is the flight engineer station. The panel includes engine, instruments, fuel, electrical, and pressurization system instruments and controls. The instrument panel is hinged and can be swung so that either the pilot or co-pilot can monitor the panel when no flight engineer is included in the crew. There are substantially fewer instruments and control levers in the cockpit than in today's transports, which is typical of the overall simplicity achieved in this new airplane. The control runs from the pilot's control columns and rudder pedals to the empennage control surfaces are simple. No sharp bends, no complications. Control cables operate basic flight controls through spring tabs. There is no mechanical or power boost. Pilot effort moves the control tabs, which in turn cause the control surfaces to move throughout their range of travel. All control surfaces are aerodynamically balanced. This system of control has been fully proven on the Boeing B-52 jet bomber. Also proven on the B-52 is the system used for longitudinal trim, the adjustable horizontal stabilizer. The stabilizer is moved to change its angle to trim the airplane through a motor control or manual system. The lateral control system handles the airplane easily and positively at all speeds. The ailerons have the same type of tab as the rudder and elevators. Supplementing the aileron controls are the hydraulically actuated spoilers on the upper surfaces of the wings. Spoiler operation is modulated through connection to the inboard aileron control system. Up spoiler with the up aileron reduces lift, increasing the rate of roll. The spoilers not only augment lateral control, but also double as air brakes. With all spoilers extended symmetrically as air brakes, the airplane rate of descent is greatly increased. They may be operated as a part of the lateral control system at the same time they are in use as air brakes. The drag brake function of the spoilers is useful to quickly and easily control the rate and angle of descent on final approach for landing. The highly efficient double-slotted wing flaps are set at a moderate angle for takeoff, enabling the airplane to become airborne with a minimum runway used. When fully extended, they provide maximum lift for low-speed approach and landing. They can be positioned to any degree as pre-selected by the pilot and are hydraulically operated in symmetrical pairs. The position of each portion of the four flaps is shown on indicators in the pilot's cockpit. There is exceptional accessibility to the flap tracks, hydraulic lines, and control cable runs. The Boeing jet transport is supported by a conventional tricycle landing gear incorporating four-wheeled main trucks plus a dual-wheeled nose gear. The four wheels of each main gear permit use of standard size wheels and provide increased tire surface on the runway, resulting in improved braking. The landing gear retraction sequence. The control lever in the cockpit is operated by the pilot. The doors open, the gear retracts, the doors close. The nose gear operates simultaneously with the main gears and in the same manner. Stopping the gear down sequence momentarily shows inside a main gear wheel well the maintenance accessibility of hydraulic components, lines, and valves. Inside the nose gear well, the same accessibility prevails. The nose gear is hydraulically steerable. The landing gears can be lowered at high air speeds to serve as air brakes in combination with the spoilers, making possible higher rates of descent. The background of the new Boeing jet transport includes over 21,000 hours of wind tunnel research on swept-wing multi-jet aircraft and over 5,000 hours of test flying on the B-47 Stratojet and the B-52 Stratofortress. This new jet transport is 130 feet in wingspan, approximately 11 feet less than the Stratocruiser, and 128 feet long. The tail, 38 feet above the ground, may be folded to reduce the ground height to approximately 18 feet. The four engines on the new Boeing are Pratt & Whitney turbojets, similar to the military J-57 engine used on the B-52. The jet engines are suspended below and forward of the wing on struts, similar to the installations on the B-47 and B-52 airplanes. This method of pod mounting the engines has many advantages, including ease of engine change. These quick disconnect fittings are for electrical connections to the engine. The quick disconnect fluid line connections to the engine are on the opposite side. Disconnect them, remove 3 bolts which connect the engine to the strut, and remove the engine. The cowling around the engine is quickly removable for ground-level maintenance access. The cowling can be raised and supported for access without removing for quick minor adjustments to the engine. After closing the engine cowlings with quick-acting simple fasteners, the jet transport is ready for engine start and taxi tests. The lightweight Boeing air supply cart, powered by a Boeing Model 502 gas turbine engine, supplies the compressed air necessary to start the turbojet engines. The compressed air hose and electrical power cables are connected to the right side of this prototype airplane. The airplane is completely instrumented. Oscillographs record flight control and structural data. Ground recorders log accessory and engine temperatures. And photo recorders obtain performance and power plant information. During the taxi tests, the airplane is run through a wide speed range to check the engines in operation, brake effectiveness, and all flying controls as much as they can be without taking off. During these taxi tests and on later air tests, flight engineers and observers were aboard in addition to the 2 pilots. On the taxi runs, the airplane's excellent maneuverability and turning radius is checked. The outstanding qualities of the airplane are derived from some 37 years of Boeing design and manufacturing experience. This background includes a multitude of bomber and transport airplanes from the B-9, the first bomber to fly more than 200 miles per hour, up to the present B-47 and B-52 multi-jet bombers and the Stratocruiser. Taxi runs at relatively high speeds verify that the airplane is ready for flight. In the early afternoon on July 15, 1954, Tex Johnston, Chief of Flight Test for the Boeing Airplane Company, signed for the new jet transport and climbed aboard with Dick Lesh, his co-pilot. The initial flight was from the 5,400-foot runway at the Renton Municipal Airport, adjacent to the Boeing Renton plant where the new jet transport was built. The airplane weighed in at 110,000 pounds for the flight. Calculations indicated it would be airborne after approximately 2,200-foot ground run and should be at roughly 600 feet altitude as it passed over the end of the runway. It would then climb to a medium altitude, 20,000 feet, and carry out a low-speed shakedown flight. Tex waved to his family, closed the cockpit window, and prepared to taxi out.
Boeing 707 cleared down the active runway into position at the south end. Roger.
Renton Tower, this is a radio truck. Permission to cross the runway requested.
Radio truck cleared across the runway.
Renton Tower is Boeing 707. We're cleared to come up on tower. 707, roger. Test, you read? This is Tex. We've been climbing for 8,700 feet. All engine operation is normal. Hydraulic pressures are normal. The airplane feels good.
The red lines line up so that, as far as we can tell in the airplane, that the gear is down and locked. We're coming in. Over, flight test.
1 hour and 25 minutes after takeoff, the new Boeing lined up for landing on the main runway at Seattle's Boeing Field. The airplane approached from the north and touched down. The maiden flight of America's first jet transport was over. The airplane taxied in, and when it had been parked, the pilot and co-pilot were congratulated by William M. Allen, president of the Boeing Airplane Company, George Martin, chief engineer, and George Shirer, chief of technical staff. TV commentators interviewed Dick Schlesch and his family and Tex. Flight test data gathered during this initial flight was analyzed, and the airplane was immediately prepared for a flight the following day. 6 flights were made on the new airplane within the next 7 days following the initial flight. The airplane was flown above 42,000 feet altitude and at airspeeds in excess of 550 miles per hour. Aerial refueling formating capability with the B-52 was demonstrated. The age of the jet transport is here, ushered in by the Boeing prototype model 707 airplane. Through continued testing and operation of this prototype airplane, early realization of an effective operational jet transport for airline use is assured.